Hi, this is Yorick, and today I want to talk to you about spinning up an Ethereum 2 node for staking easily using technology called Docker and Docker Compose. Don't be afraid of that. That's not just for programmers. It's a way of really easily bringing programs up. I think this is a lot easier than just following a bare metal guide. That having been said, Somer Esat's guides are awesome, and I've used them in this project to create these Docker environments. If you don't know what Ethereum 2 is, start there. There'll be a link in the description to a primer, and then come back. Right? I'm gonna briefly talk about the software components that run in there. I'm going to talk a little bit about Linux security. Then we're going to create a key. We're going to import that key into the validator. Going to bring the node up. Take a look at depositing some Ethereum to the contract on the Ethereum 1 chain. Before I get going on the entire video, I should also say nothing here is financial advice, and nothing here is the be-all end-all of security. Ultimately, you are responsible for your own client security, key security, server security, keeping your Ethereum safe, right? That's not my responsibility, that is yours. I'll give some pointers of what I think are good ideas, but ultimately do your own research. So you don't want to use your machine that you use for email, web games, etc. to access your node server. If at all possible, avoid that. Have something clean. I'm going to use a few tools here to help me out. I'm on Windows 10. I'm going to use the Windows Sandbox. I'm going to use a thumb drive that is encrypted with BitLocker and secured through a YubiKey. I am going to use KeePass and WinSCP on that. I'm going to use some SSH key authentication. I'm going to walk you through all that. I'm not going to talk about too much about the security, the physical security of the server. Things like drive encryption, RAID for that kind of stuff. Go look at other guides as to if I'm worried that my server might get stolen, how do I keep that secure? How do I do encryption? For my case, I'm probably going to run it ultimately on a ZFS with ZFS native encryption. All right, let's get going. Let's start with, I prepared myself a BitLocker encrypted drive, and I'm just going to enter that and unlock it. There it is, unlock drive F. And I do this with the YubiKey password. There's going to be a link as to how that works. So here's my unlocked drive. I have a sandbox file here. Again, there'll be a link as to how that works. And this sandbox file starts the Windows 10 sandbox and passes this ETH folder here through to the sandbox. So that's where my portable programs are, WinSCP and KeePass. That's also where I'm going to be storing the SSH keys and all passwords, and ultimately the key store that I will generate for my validators. Yeah, so start the sandbox. Now, in order to be careful here and not have the various keys I'm generating ending up in the clipboard on my main machine, I'm going to maximize this, right? So that way I know where I am. I'm only going to be in this sandbox. All right, let's start with looking at some instructions. So the project lives in GitHub in the ETH2 educators, and it is the ETH2 Docker project. And then we have here a link to the guides by Somer Esat. I'm actually gonna, these are bare metal guides, and I'm actually gonna open those right now because there's a nice graphic in there that's gonna help us out here to understand what's going on. So what is the Ethereum node? what components are part of that. You'll have a Linux server, and then it will talk to world about other things. So in the Linux server will be the actual client software that's going to beacon node and a validator client. These could be in the same executable or they could be separate. It depends on the client. The beacon node constructs the Ethereum 2 chain. The validator signs attestations and makes proposals. It uses validator keys for this. Inside the validator client, you can have one or multiple validators. Each validator is responsible for 32 ETH that you staked, right? The beacon node talks and synchronizes with an Ethereum 1 chain node. This will be, in this example, it'll be local to the machine, to this server. This could also, however, be a third party that allows you to access them with an API through HTTPS or WSS. And then that peers with others on the blockchain, and so does this beacon node. So this Ethereum node gets a pruned full Ethereum 1 chain, and then the beacon node gets an Ethereum 2 chain, and the validator talks to the beacon node. Okay, there could also be a slasher here talking to the beacon node. That I don't have in the project yet as of October 1st, but it'll come in there. All right, let's take a quick look. So, assumption, we have a Linux server set up with a non-root user, and we're going to go through the setup for it. There are 4 clients currently supported by this project: Lighthouse, Prism, Teco, and Nimbus. Choose one that you like. I'm going to show you how this works with Lighthouse. Prism is fine. Teco is a Java client, needs a little bit more RAM. Nimbus, as of October 1st, still has a little bit more work to do than the others, but is a perfectly fine client as well. Optional components would be a local Ethereum 1 node, such as GöETH, needed to propose blocks, or you can point to a third party, and then a Grafana dashboard for just some, seeing what's going on. Nimbus currently, as I'm recording this, requires an archive source of ETH1 chain data and third party via WSS. So if you're using Nimbus, keep that in mind, right? Let's start with install prerequisites. We're going to install on Ubuntu. So I'm going to bring up a PowerShell, and this actually has SSH built in, so I'm going to use that to log into my Linux server with a non-root user. And fingerprint, that's right. And it's going to prompt me for a password. For that, I need my key pass. I've created this database earlier with a with the password, just the password for the non-root user in there already, and I printed out the emergency parts. Side note, completely beyond this video, but do think about if you're staking and you're passing away, how are you handing all this tech to your heirs, right? How do they get access to this? Okay, copy this password in here. All right, so now we need prerequisites. So first we're going to update the OS itself. This has already been done here, but I'm just going to show you what that looks like. And then we're going to install Docker and Docker Compose. Those are the parts that run the client in a environment that has been already created for the client, so you don't have to worry about what's on your Linux machine. And Git. And Git is only used to pull this project itself in. That's all it is. Maybe if I can copy, paste, there we go. And yes, we do want to do that. I should also mention the probably belonged in the beginning. This project builds clients from source currently. Started out that way. That's how so many ESATS guides worked. It also means that I'm not overlapping with the client teams. As the clients get more robust, we'll have to see whether it makes sense to allow a binary option in here, or that's just duplicating what the client teams are doing. Okay, prerequisites are done. Let's go to the next part. Choose a client, do initial setup, then we're going to build the client, generate deposit files, import the keys to files, run the client, finalize deposit, set up Grafana dashboards. Maybe not exactly in this order. So choose a client and do initial setup. All right. Non-root user, I already have that. Clone the project, let's do that. So I'm going to go into my home directory, clone this project. And get into the project. Okay. I'm also going to make life a little bit easier here. This is going to be difficult with the colors, so I'm going to change things around a little bit. My background is going to be light gray and my text is going to be black, and hopefully that's going to be reasonably readable, legible. Okay, ETH client I wish to run, Lighthouse, Prism, Teco, or Nimbus. And source of ETH1 data, GöETH or third party, and whether to run Grafana. So I'm going to do Lighthouse, GöETH, and Grafana. Copy the environment file, copy default env to .env, and then adjust the contents. So I'm just going to do a nano.env. All right, the local UID, that's actually kind of important. This is the user ID of the non-root user. So by default, that's going to be 1000 for the first user. Do an echo $UID, see whether that's what it is. If you need to adjust for the user you're going to run this all under. The compose file, this determines which client I'm using. So let me go through that for a second, right? The default I have in here is LH base, which is the Lighthouse base, GöETH, the Ethereum 1 node locally, and Lighthouse Prism Grafana, Grafana for Lighthouse and Prism. If I wanted Prism, this would be Prism base and the rest, right? I wanted Teco base, GöETH, and then Teco Grafana. Nimbus, Nimbus base, GöETH, and Nimbus Grafana. If I wanted a third party, just leave out GöETH, take that out of the entire compose file string, and then adjust the ETH1 node here to whatever third party it's going to be, right? Graffiti, that is going to be just that. It's a graffiti that you're sending out. If you want a specific string, do that. Sometimes during testing, you get POAPs for putting the right string in here. So, set that to whatever you like. Number of validators to create with deposit CLI. So assuming you're using the deposit CLI in this project, how many validators are you going to run, right? You're going to run one validator client that can have multiple validators. Each validator locks up 32 ETH. So how many are you going to run? The default is just one deposit of 32 ETH. Okay, done with that. There's some firewalling and stuff going on. So I'm going to come back to that actually. A little bit of Linux security. Before we do that, let's go see what's next. Build the client. Sudo docker compose build. That sounds easy. Copy, paste. Okay, so now that's going to do its thing. And while that is running, I'm actually going to open a second SSH connection. And I'm going to start thinking about Linux security with you a little bit. So let's log in here. So the things that we probably want to do here with the setup is firewalling just on the Linux server itself, and I'm going to briefly talk also about what that means if you are behind NAT and what you need to forward, and time synchronization and SSH key authentication. So starting with firewalling, you need to know which client you're using, and that determines the ports. So 3303, that's your local ETH1 node. Since I am running a local ETH1 node, I need this. This should be open to internet. And then 9000 TCP UDP, that's your Lighthouse Beacon node. Again, open to internet. Grafana, not open to internet. Locally only, right? This is insecure HTTP. If you need to get to Grafana remotely because this is a VPS, consider SSH tunneling that. There's a to-do here to add some form of reverse proxy. If you want to, do that work and bring a PR in, I will welcome that. Traffic or Nginx, whichever, Nginx. And then SSH, of course, this needs to be open. Only open to internet if this is a remote server, a VPS. Otherwise, should not be. And you should always use key authentication, not password authentication. I'm going to be a little bit careful here. If I get this wrong and I don't add SSH, I'm going to lock myself out. Okay, so I'm going to allow SSH. So I'm going to do a sudo UFW allow open SSH. And then I'm going to allow GöETH. Again, only needed because I'm actually running a local GöETH. Would be the same for other clients such as Open Ethereum, Bisu. I'm going to allow 3000 TCP for the Grafana dashboard. Again, please do not forward that to internet. And then I'm going to allow 9000 for Lighthouse. Okay. Now I want to look at that and just see what does that look like, right, before I enable it. Because I gotta make sure that I have this UFW allow open SSH. This is the one thing I can't get wrong. If I get any of the others wrong, I can change them, but open SSH, if I get that wrong, then I need to go into console on the device rather than SSH to get it back, because I'll have locked myself out. All right, we're going to enable the firewall. And it warns me that this may disrupt my SSH connections, which is entirely right. And apparently I'm still good. And then I'm going to take a quick look at these things with the status numbered. And you can see here I've got OpenSSH, GöETH, Grafana, and Lighthouse. Right? Good. Time synchronization. So by default, time date control on Ubuntu does the synchronization. NTP service is actually inactive here. Typically it's active. I've disabled this earlier. So you want to set that to no. And then you want to install NTP. And why are we doing this? Because time is important, right? You can be marked offline or you can miss an attestation if your time isn't right. And the default is okay, but not as good as an actual NTP. So we're going to go with a real NTP client here and get that installed. And then when that's up, I'm going to take a quick look and see that it works. So what you see here is these pull servers, which then pull in these servers here. So this is looking good. I'm connecting to them. They have different offsets and jitters. NTP is a consensus-based protocol. So if one of these servers is a bit more off than others, that's not a problem, right? As long as my pool as a whole is okay, I'm fine with that. All right, next I'm going to set up SSH key authentication and disable password authentication as a security measure. So I'm going to open yet one more Windows PowerShell. Create a pair, SSH keygen T, there we go, add 22.5, there we go, do this. Enter a file and then passphrase. So I don't have a passphrase. Let's create one. SSH passphrase. Save that. And this is inside my encrypted USB key. So this is going to survive, right? That's important because everything in here is gone when I shut down the sandbox. Okay, that's great. We have this. So now I want to take this public key that was just generated and I'll copy that as well, because this too is going to be gone when I shut down the sandbox. So I'm going to go in here and just copy this in here. So now when I start the sandbox, I can take these files again and copy them into .ssh for the default sandbox user and keep using these, right? Okay. So now I'm going to copy this key. I don't have an SSH copy ID that exists on macOS or Linux, so I'm going to do it manually. I'm going to cat this. There it is. Copy that, and then here do a nano. My .ssh directory already exists. If not, you would have to create it. Authorized underscore keys, and then just paste that in and exit and save. Exit this. Alright, first we're going to test that I can get to this now without being prompted for a password. I'm being prompted for the passphrase for the key. That's correct. That's what I want. And I'm in with the key, so that's great. Next part, now that I know the key works, I want to, so test login, we just did that. We're gonna edit our SSH config and turn off password authentication. Yeah, I don't need this anymore. Password for sudo. So you see I'm doing a lot of password copy paste because I have strong passwords, and that's why I'm in a sandbox. I don't want this in clipboard history. I don't want anything, you know, that might I might have contracted on the Windows box, as careful as I am, to be able to read the clipboard. So I'm going to look for password. Look again and again. There we go. Password authentication, yes. This will typically be commented out, so you want, it'll be like this, right? So you want to remove the comment character and set password authentication to no, and exit and save. And then very important, restart SSH. Okay. I still have one going, so I'm happy to disconnect here and I'm not too worried about it. I'm just going to test that I'm not being prompted for a password. I'm not. Permission denied public key, that's great. And come back in with my passphrase here. And that's working, right? So that's basics Linux security. There's more to Linux security than this, but that's the absolute basics. Okay, so after building the client, we will create an Ethereum 2 wallet, validate a key store and deposit files, import that, start the client, and I'm going to show you Grafana, and then we're going to deposit. Let's see where we are. This is still building, so I'm going to pause this. This can take like half an hour at this point. You know, if you followed this far and this thing is building, go walk the dogs or something. This legitimately takes half an hour because we're building from source. Alright, so that's done. The client has been built from source, and it will build the client you chose. So in this case, Lighthouse. Edit the inf file to set the number of validators you wish to run. Yeah, one more time. Yeah, we're going to create the wallet now, and we're going to get validator keys for the number of validators that we set. So in this case, just one, just 32eth. Run the deposit CLI, asks me for the password. ask me for my language. I'm going to do English. I need my validator key store passphrase, which I don't have, so I'm going to do the key store and create that. Again, save, copy that. So the advantage of doing all this with something like KeePass is that I have very, very strong passwords, right? It also means I really need to keep that secure somewhere. Offline in this case. It's not going to be something that I have online anywhere. Do not store this online. Okay, this is my seed phrase. So, oh my God, it's showing a seed phrase on YouTube. Obviously, this is nonsense and isn't gonna go anywhere. This is GöETH, play money, and while you can use this to slash the validator behind it, there's not actually gonna be a validator running for it. So what the important part here is that you need to write this down. Don't just copy paste this. This needs to be written down and it needs to be secured offline. This could be as simple as you have it on a piece of paper that goes into something fireproof that goes into a safe, right? It could be you have one of those steel or titanium devices that allow you to set letters to keep this phrase in its exact configuration. This mnemonic phrase allows you to withdraw your Ethereum in 2 years' time or whenever, when it becomes available for withdrawal. Without this, you lose access to your funds. You cannot stress enough how important it is to keep this thing safe. So I'm going to write this down and then type it in. And while, because that takes a minute, I'm going to pause here. Okay, so the words you were given in the exact order they were given to you. I'm going to harp on that a little bit more as we go. This now creates my keys, key store, deposit, and so on. Now I want these things off this server. I'll eventually delete them there after importing them. So let's get them off the server right now. I'm going to use WinSCP. And connect to my server as my user. And now keep in mind, we're using key authentication. So I'm going to select the key file I have, right? So I say all files, and this one right here. This is an OpenSSH format, so it'll tell me I can't read that. And do I wish to make this into a PuTTY key? Yes, I do. And the passphrase for my key. And then we're going to save this PuTTY key here. And now I can log in and connect. And again, it asks me for the passphrase. Okay. The next thing I need to do here is I need to tell it that I want to see hidden files, right? So I'm going to go to Preferences and Panels and Show Hidden Files. Okay. And then here I'm going to go to Desktop, ETH. This is the USB key, the encrypted USB key I'm passing in. And here I'm going to go to ETH2 validator keys. I'm going to take, actually, why not the whole thing, right? So validator keys, just pull that in here. Okay, that's done. Don't need WinSCP anymore. Press no to enable automatic saving. So I'm actually going to save this, right? So I have it available if I need to SCP something again, which I shouldn't have to, but you never know. So now that that is done, I am going to import this into my validator client. So I'm going to import the validator, which is the validator key, into the validator client. Do all keys have the same password? They do. I only have one key. Typically, Deposit CLI creates all with the same, but if you have keys from different ways of creating them and you copy them in there manually yourself, then this is how you can decide. So this is the key store password that we created earlier. Password is correct, successfully imported. Okay, great. Now, this password is now saved in clear text inside the Docker container for this validator client. That's not ideal. So if you're worried about, oh, somebody might actually steal my machine, then you want to think about encryption. There's also ways of securing this secret further through things like Vouch and Dirk. Not currently part of the S2 Docker project, but I'm definitely going to look into that because that sounds great, right? So just know your own risk tolerance and know how you want to secure this further. If you don't give them the key here, you can also do that, not store it, but then every time you start the validator, you have to enter it yourself, right? So you're not going to survive a reboot. Start the client. We do want to do that. All right, start the client. So this is going to start GöETH, the local node, Ethereum 1 node. It's going to start the beacon. It's going to start the validator. Depending on the client, those might be the same executable. It's going to start Grafana, the dashboard. Right, now see here, this is all up and running. So let's take a quick look at Docker PS, see what is running. Actually going to make this a little bigger right now. So I can see I got my Grafana going, Prometheus feeds Grafana, node exporter shows me CPU and such, GöETH is my node Ethereum 1 node, beacon is my Ethereum 2 node, and validator is my Ethereum 2 validator. I can now look at the logs for these. Sudo docker compose logs f. Let's start with GöETH. So I see it's looking for peers. It's found one so far. It's starting to sync, right? The beacon will not start to sync until this is fully synced. On Medasha, the testnet, this will take a couple hours. On mainnet, this might take days. And let's take a look at the beacon. So the beacon, as you see, failed to update ETH1 cache. That's perfectly normal, right? I don't have a synced GöETH yet. And then likewise, the validator should tell me that the beacon node is still syncing and it cannot validate anything. So where does this come in? Because this can take days on mainnet, you have to decide when you are going to deposit. So you have a file now that you can use for depositing. You have a key store that has been imported. Until you deposit, the process to bring your validator online, or activate your validator, I should say, isn't going to start. So you can say, oh, I'm going to deposit now, right? And I know that currently with the way the beacon chain is, it's going to take, I don't know, 8 days before my validator gets activated anyway, and by that time this is synchronized. Or if you want to be more careful, you can say, I'm going to wait until I see my Ethereum 1 node fully synchronized and my beacon fully synchronized and my validator telling me it's standing by. And only then will I deposit, and then it'll take a few more days. But that way I'm not going to be marked offline because I've been activated, but my actual node isn't ready, right? So know your own impatience and tolerance for risk here and act accordingly. So now what I'm going to do is I'm going to verify one more time that I actually do have my files. Validator keys, there's my deposit data, and there's my key store, so that's looking good. And they are where I expect them, right? They're in my ETH directory, which I know is synchronized to my USB key. Again, I don't want to lose this. if this is just in the sandbox, it's going to be gone. It needs to be on a USB key that's been passed into the sandbox. Okay, so now that I know that, I'm going to remove these keys from here. Done. Don't need them here anymore, right? No reason to have them there. Keep them safe offline. Depositing would come next. I'm going to do that at the end though. Now I'm just going to go at look at the Grafana dashboard. Okay, so go to server IP 3000. Again, please do not expose to internet. It's not encrypted, it's not safe. If you need to get to it remotely, use a reverse proxy or an SSH tunnel. And this is going to log me into Grafana. The default is admin, and then I'm going to create myself a Grafana login. Admin. Save that. Save it here again so it survives. Copy that password. Once, twice, and submit. Never. Okay, Grafana, I'm logged in. Now I need a data source and I need a dashboard. So I'm going to go here to the gear icon, data sources, add data source. It's going to be Prometheus. See here, this is HTTP localhost 1990. This is going to be HTTP Prometheus 1990 because we are running this in a Docker container called Prometheus. Okay, save and test. Data source is done. Import a dashboard here, plus and then import. So now I want a dashboard. Could be really any you can find out there. There's a couple that Somer Esat had linked to that I'm linking to here as well. So let's take a look at the Lighthouse dashboard. This is just JSON data. Control A, Control C, Control V. Paste it in here. Load. Tell it I am connecting to Prometheus, the one I just created, and import. And here we are. Now I've got a dashboard telling me what's going on. The client teams are working on an actual proper UI, so that's going to get better as well. Okay. Auto start the client on boot. Not a bad idea, right? So since I'm already saving the password inside my validator, I might want to make sure that when I'm booting this device here, my server, the client comes up. Side note, you should also make sure that in the UEFI BIOS you have set this so that on power loss it comes back up when it gets the power back. Right? The default I think is that it might actually stay off. So you want to make sure it comes back on and it does not prompt. There's another setting there, prompt for F1, right? It does not prompt and it just comes back on, because otherwise if you lose power while you're on vacation or something, and this is in your home, you're going to be down, right? And you're going to get offline penalties. Offline penalties aren't huge as long as only you are down and not the rest of the Ethereum 2 world, but still you want to avoid it. So we're going to copy this sample here and then we're going to edit it. This is the Ethereum 2 service. This is specific to Ubuntu. If you're not using Ubuntu, then you know what you're doing with regards to creating a service, and you don't need me to tell you how to. The only thing you really need to adjust here, if everything else is the same, is the username, right? If you brought this into Eth2 Docker, then just put in the username here. If you have a different working directory, adjust the working directory as well. And just save that. Okay. Now I'm going to test this. So we're going to do a daemon reload. My instructions actually say to start it, but that would be a great test because we're already started, as you can see. So I'm going to do a sudo docker compose down. So I'm going to take it down first. And then I'm going to see that the service brings it back up. Just going to do a quick docker ps to make sure that after the down it's really gone. And nothing there. And then we're going to do a start this service that we created with for systemd, right? And as I can see, everything's back up. Great. So that worked. So now if I want this to happen on boot, I'm just going to enable that service. Okay, wonderful, done. Right, if that's all you needed and you already know how to deposit, you can end here. Otherwise, I'm going to show you how to do deposits. So we're going to shut down the sandbox because I can't do the deposit from inside here, only because I'm using a hardware wallet and I can't pass USB into sandbox currently. Microsoft might change that in future. So you're going to be really careful about where you do this from, because while right now it's play money, eventually it's going to be real money. Just make sure I have my passwords. So I got my Etherlinux, my Grafana, my key store, my passphrase. Verify once more that you have your mnemonic written down and that you know how to secure it. Verify that I have my key here for SSH key for logging in, that my validator keys are there. Okay, that's all looking good. So now I can shut down this sandbox. Once Windows Sandbox is closed, all of its contents will be discarded and permanently lost. That's why I do all this triple checking, right? There we are, gone. Okay. Now we're going to use MetaMask, a browser add-on, and we are going to use the Launchpad. So I'm going to go to medasha.launchpad.ethereum.org for this test network and say I want to get started. I'm going to walk you through these warnings here. I don't want to just do next, because this stuff is important. So validators receive financial rewards, and you're going to post, in this case, GöETH, which is the play money, as collateral. This is a one-way deposit to the deposit contract. So you're not getting this back until maybe 2 years from now. You need to deposit 32 GöETH or ETH on mainnet. This process cannot be reversed, right? Be very clear about that. You gotta be online. So if your validator goes offline for whatever reason, you're gonna have a penalty of currently 0.13% of your stake per week. That penalty will go up after month 5 of Ethereum 2. Not quite sure yet how high, because that's not been set. That's when just you are offline. If there is a catastrophic client bug somewhere and more than 33% of the network goes offline, then you have something called quadratic leaking, and that's going to really hurt. Within 13 days, you're going to leak 16 ETH. That's there so that at least at the worst case, 13 days after it started, the network is back up and running. Most likely much sooner, because people will want to fix their validator clients, right? So be aware of this. If it's just you, the penalty is small, but if it's a whole bunch of clients, then you want to be back up as soon as possible. Slashing. So when you have your validator keys in more than one validator client at the same time, that's one way to get slashed, right? Or if your time is wildly off and you somehow manage to sign something anyway because everybody else's time is wildly off, then and then you come back and you sign at the current time, then you could get slashed, right? That's called a surrounding vote, and that'll get you slashed. So be aware of this. As long as you have your validator keys in only one client and there aren't any absolutely catastrophic bugs that lead to slashing, you will be fine. Key management. So that's the mnemonic again, right? The seed. This is the only way to withdraw your funds. If you don't have that, you have nothing. So that has to be kept securely offline. Don't put that online anywhere, you know. Signing keys, those are the validator keys. We're also keeping these quite secure offline because with the signing key, somebody could slash you. They could, maybe go in and say, well, we have your keys and we have your password, so give us money or we'll slash you. If you ever think your keys have been compromised, if you have indication of that, you would have to voluntarily exit your validator, which you can do. But then you're not going to get your deposit back until 2 years from now or so. There are no transfers. You can't transfer between validators. You can't withdraw, right? That's all years in the future. So you deposit your ETH and it's locked into that validator and you're going to be online. Again, no way to voluntarily exit and then restart. You can voluntarily exit, but you can't come back in, right? And there are early adopter risks because this is all still not live as this is going up, and when it is live, it's going to be early, right? So this tells you how to set up a node, which we just did. So we're going to say, yes, we're keeping our keys safe, and we've got our mnemonic phrase, Jeebus. And before I do this here, I actually need some GöETH, right, to stake. So I'm going to look at my MetaMask that I set up earlier, and I'm on the GöETH test network. This is really important. Don't be on the main network, right? We're testing right now. So GöETH test network is what we're using. This is connected to my Ledger device. I'll copy this address to the clipboard and from Discord get myself some playeth. This may actually not work because I did this just a second ago. It probably will tell me you cannot again. That's right, don't be so greedy. I use a different Discord. I do it in here. Prism Discord is good for this as well, as is the ETH Staker Discord. And now I should be able to grab my deposit data. Again, this is all public data. I'm going to use MetaMask, telling me right now you don't have enough play money. So it probably takes a minute. There it is, right? Continue with that. So one validator, 32 ETH, or in this case, GöETH. I understand that if I lose my mnemonic phrase, just harping on this, right? If I don't have this, I cannot withdraw my funds. Aware that there are early adopter and slashing risks. Aware I cannot undo this once I've sent my ETH. It is locked up forever. And I know how to check that I'm sending my ETH into the correct deposit contract. Okay, wait, what? Right, so there's a deposit contract on the Ethereum 1 chain, and you got to be sure you're sending this to the right address. It's quite likely that once this goes live, there's going to be spoofs of the launchpad somewhere. So you're going to look at EIP 2982, and there is a deposit contract address to be determined as of October 1st, but this is going to get real. So whatever that address is going to be, find a really reputable source for that and verify, right? If there's a link in here, that's probably not right, right? There's a learn how to do it safely here. How do I avoid phishing, right? Get familiar with that before you try this on mainnet. Okay, I'm going to see that my Ledger is still unlocked, that my MetaMask is connected to GöETH and the Ledger, and say initiate this transaction. And that's going to be, so this is my address. This I would now copy and verify against the EIP, against the correct deposit address. Confirm that. And for some reasons, that failed on me. Same thing that happened earlier. So we're just gonna restart this all over. once more, confirm this address is right. Confirm. Okay. Now this should show up on my key. And now what I need to do is the key is going to show me the amount. And it's going to show me the address again, right? So I need to now make sure that the address I'm getting on the key is indeed correct, that the fees are right, and then accept and send. Okay, transaction started. Wonderful. Now next thing I can do is I can look at my validator on the Medasha Beacon Chain Explorer. So for that, I'm gonna go grab myself my public key. Again, everything in deposit data is public, right? There's nothing secret in here at all. The secrets are in key store and they're encrypted. So transaction has been confirmed. Could not view the validator, a little too fast. So it may take a minute before this is actually visible here. And it was actually less than a minute, it was just a few seconds. So now I have this setting here as index pending. The ETH1 deposit has been made. It'll take around 8 hours until the beacon chain has processed this. At that point, it will then go into the activation queue, and that depends on how many are in the queue. We've seen hours on the smaller test chains. We've seen 9 days on the Medasha test chain. How much that is going to be on mainnet is anybody's guess. So at this point, everything is done. You'd be running around 2 safes, keeping your written down mnemonic safe, putting your encrypted USB key into a safe, and yeah, I hope this has been helpful to you, and I wish you a good day.